Welcome back, Math 136 students. Today we're going to talk about Chapter 1, Section 5, and what I'd like to do is first talk about interval notation. So we have 4 intervals here, and I'd like to write them in interval notation, and then finally I would like to graph them using that interval notation. So we have x is greater than a, which means that a is actually going to be your lower bound, which means it goes on the left-hand side of the ordered pair, and since there is no upper bound, then this would go to positive infinity. Since this cannot be equal to a, we then write this with a parenthesis, and we always write parentheses around positive or negative infinity. Going to the right here, I'm going to put a in the center of my number line, and since this cannot be equal to a, I'm going to use a parenthesis. Since it's greater than a, I'm going to open it to the right, and I'm going to shade to the right, meaning any value that is greater than a but not equal to a would satisfy this inequality. Okay, going down to the second one, very similar problem, but now I have less than or equal to. So my upper bound happens to be a, so I'll put that on the right side of the ordered pair. However, there is no lower bound, so this will be represented by negative infinity. All right, put parentheses around infinity. However, on the right side, I'm going to put a bracket because we can't actually have this value equal to a. Again, going over to my number line, I'm going to represent a in the center of the number line. And in this case, I'm actually going to use a bracket to label a, and I'm going to open the bracket to the right, meaning less than, and I'm going to open the bracket to the left and shade to the left because we're talking about x or all the values less than or equal to a. All right, these two are actually compound inequalities where you're given an upper and lower bound. So in this case, you're given the lower bound a and the upper bound b. Since neither of them can be equal to a or b, you put parentheses around both. I'm going to represent this mark as a and this mark as b. And since we're dealing with all the values that are greater than a and also less than b, we're talking about a compound inequality, an and compound inequality, and it's going to be, the shading is going to be between a and b, meaning all the values between a and b satisfy this compound inequality. All right, last one, we've got, again, a and b being our bounds, so it's going to be a comma b, and we have a bracket around a since it can be equal to a, but a parenthesis around b. Again, going over to the number line, we still have our mark for a, our mark for b, and for the shading, it's going to be in between. However, and I think I forgot this with the previous one, with a, we need to represent this boundary, so it's going to be a bracket, and with b, it's going to be parentheses. My fault, with the one previous, it's going to be parenthesis and parenthesis opening towards the center. Okay, now with numbers 1 and 2, we're actually going to solve these inequalities, and to solve them, we're going to use pretty much the same process we would for an equation. The difference, there is one small difference, and when we see that in these two problems, or maybe the next one, I'll make sure to explain what I'm doing. We are going to write these solutions in interval notation, and the reason being is that with an equation there was one solution. For linear equations, that is, there's one solution. For inequalities, there's infinite solutions. There's a region of solutions, so therefore we write them in interval notation. First thing we're going to do with this is distribute. So we'll distribute the -3, so this will be -3 plus 3x is less than 12. We're then going to add 3 to both sides, and so we get 3x is less than 15. Divide by 3, and so x is less than 5. Finally, we're going to write this in interval notation, 5 being the upper bound, since it is x is less than 5, and that means since there is no lower bound, it's negative infinity. Always put a parenthesis around negative infinity, and since it can't be equal to 5, it's got to be a parenthesis around 5 as well. Okay, number 2, we're going to do about the same process. We're going to distribute the 1/3, so we will get 3x plus 4 is greater than 1/3 x minus 2/3. All right, then from here, I'm going to actually subtract 3x to both sides. And this will result in 4 is greater than, so 1/3 minus 3, so that's 1/3 minus 9/3, which would then be negative 8/3 x minus 2/3. I'm going to add 2/3 to both sides. Okay, and that cancels this out. So 4 over 1 is really 12 over 3, so that becomes 14/3 is greater than negative 8/3 x. Finally, what I'm going to do here is multiply by the reciprocal. So when you have a fraction and you have to move it over, we don't divide, we multiply by the reciprocal. So that will be negative 3/8. So multiply the left side by negative 3/8. Okay, on the right side it cancels out. On the left side the 3's cancel out, not the negative of course. Now 8 and 14 can be reduced by 2, so that produces a 4 and a 7. So the answer here is negative 7 over 4. On the right side we have x. However, and this is where the big change is, this inequality symbol, because we multiplied by a negative, does get reversed. So this is actually x is greater than negative 7/4. Again, the inequality symbol got reversed because we multiplied by a negative, and the same rule actually applies when we divide by a negative. So I'm actually going to rewrite this in a different way because I'd like to write it with the x on the left-hand side. So I'm going to put x first. Now, since the inequality is opening towards the x, I need to be consistent and have it open towards the x as well. If I flip everything around, and then we have negative 7/4. Finally, I'm going to write this in interval notation, and again, since x is greater than negative 7/4, negative 7/4 happens to be the lower bound, so I have a parenthesis around that, and then it goes up to infinity, parenthesis around that. Okay, the last two are slightly different. These are actually compound inequalities, and in order to solve them, we're going to do very much the similar process, but with a slight twist. So here we have 4 minus 3x inside. We need to solve for x. We're going to subtract by 4, but to subtract by 4, we are actually going to subtract all 3 sides of the inequality. So this is negative 9 is less than or equal to negative 3x, which is less than or equal to negative 2. Finally, we're going to divide by negative 3 all 3 sides. Now remember the rule I just stated, how when we multiply or divide by a negative, we do reverse the inequality symbols. So this is actually positive 3 on the left side, x in the middle, and on the right side it's actually going to be positive 2/3. However, instead of x being greater than or equal to, it's now less than or equal to, and instead of x being less than or equal to negative 2/3, or sorry, negative 2, it's going to be greater than or equal to. Okay, so if we were to rewrite this, again, this is slightly different. We usually use put the lower bound, which would be the 2/3, on the left side, and we usually put the upper bound, which is the 3, on the right side. So I'm going to rewrite this. As long as I'm consistent, I can do that. I'm going to put the 3 on the right side. I'm going to put the 2/3 on the left side, and I'm going to reverse both the inequality symbols because I'm flipping everything around. So this will be greater than or equal to x, which is less than or equal to 3. All right, so this makes it very easy to do the interval notation, which is 2/3, comma 3, and since it's greater than or equal to, bracket, less than or equal to, bracket. With number 4, we're actually going to start off by multiplying everything by 4. So we're going to clear that denominator. All right, notice I use parentheses. That's actually very important to use parentheses, so please do so as well. And that clears off the 4 here. So now all of a sudden I've got negative 12 on the left side, which is less than 2x minus 1 in the middle, and that's less than 0. I'm going to add 1 to all 3 sides like I did in the previous problem. That's negative 11, less than 2x, which is less than 1. I'm then finally dividing by 2 to get negative 11 over 2. X happens to be greater than that and less than 1/2. Negative 11 halves is the lower bound, and since it's not equal to, we write parentheses. 1/2 is the upper bound, write parentheses with that as well. All right, good luck, and let me know if you have questions.